What's up? Welcome back. This is day 3 of the Advent of Code, and you're going to see how to solve it with Ruby. So today's problem is called rucksack reorganization, and the input looks scary. It's like all of these random numbers, but as you read through it, we're still on day 3. I think these just continue to get more and more challenging and increasing in difficulty as we go throughout all of the Advent of Code. This is day 3 of 25, so it should still be relatively easy. So let's jump into it. So each of these rows represents a rucksack, and each rucksack has 2 compartments in it. So, when you're like opening up the zippers for your pockets, I know my kids they're like, Dad, where did you put my snacks? Is it in the small front pack or the big back compartment, or is it in this other little pocket? These rucksacks that the elves are carrying, they just have 2 giant zipper compartments, and they're the same size. This is like all of the items that are in the first half, and this is all of the items that are in the second half. Something happened where everything is not in the right compartment. And so what we need to do to help the elves reorganize is figure out which items appear in both compartments. And then we're going to just figure out, basically what we want to do is figure out which letters are in the first half and the second half of each rucksack, and there should only be 1 occurrence. So for this first rucksack, if we look at the first compartment, that is like V, J, R, all the way through R. So that's going to be this first half of the rucksack. And the second half is going to be H, C, S, blah, blah, blah. And there's only 1 item that appears in both the first half and the second half, and that is lowercase p. So the first part of the challenge is go through each of these rows, and we want to split them up into the first compartment, second compartment, and then figure out what is like the one thing that's on the left and on the right. So we're going to copy this. Let's head over to our terminal, and we're going to make a new day 3 directory here. That is a directory, day 3, and then we're going to open up day 3.rb, and let's just dump this in again at the end as our rucksacks. So what we want to say is our data is going to be data.readlines, and then we can say, let's just do like p data dot, or maybe the result is data dot, we want to remove all the new lines, map chomp, and then we want to say for each of the rucksacks, I think we want to split them into all of the individual characters. So yeah, let's do like dot map. Can we do map chars like that? Does this give us what we want? I don't know. Let's say p result, and we'll come over here and say Ruby day 03, day 3. And okay, this is looking pretty good. So this gives us an array of arrays where the inner arrays are each of the rucksacks with their entire compartment, right? And so now what we want to do is take that and cut it in half. So we want the first half and we want the second half. So what I think we can do here is then map it onto another thing where we can say like one.each slice, where each slice is the length of half of the result. So under one.length, and I think that should give us, or should split it up into a bunch of half things. I guess that gives us back an enumerator. We just call 2a on that, and then, I don't know, it's whatever. We'll call that good. All right, so this is giving us now an array of arrays, or it's an array of arrays that are each 2 elements long. So here is the full thing. Wait, no, that's wrong. So that's an array of arrays that are the full length. So we need length divided by 2 because we want to split it in half. So let's try this again. There we go. Okay, so now each inner array has like this first part and a second part. And I kind of like recognize that this is ending in WR. This one's starting with HCS. So I think we've figured out the compartments in the backpacks correctly. Now what we want to do is figure out which elements in the left or in the first compartment are the same as the elements in the second compartment. For this, we can use set intersection. And so now I think what we want to do is just map each of those onto the first. And in fact, can we do that here? Can we just say left and right is equal to this? And then will we get that? No, okay, so this is what we're going to do. We're going to now say dot map, and this is going to give us, so we'll use array destructuring in the arguments. So here we'll say left and right, and then we want to say left intersect. Okay, let's see if this works. Boom. All right, that's it. Now we have the items that are the items that are like the same in the left section and the right section. So if we again look at the first compartment here, the lowercase p is in the first compartment. And if we look at the second compartment, lowercase p is in the second compartment. And so that is like our first answer. And then if we look at our examples here, they tell us that, okay, in the first rucksack, we're looking for lowercase p. So that works. Let's look at the others. Big L, big P, VTS. Big L, big P, VTS. Good. Okay, so now we've got the right letters. Now we can just say flatten. And now what we want to do is figure out what are those priorities. So the priorities here, to help prioritize the item arrangement, every item type can be converted to a priority. Lowercase items A through lowercase z have priorities 1 to 26. So again, we can use like ASCII, their ASCII character code thing. And so again, we want to map this onto something. And this is going to be like, yeah, so this is going to be _1. If I don't know, I guess we can use regex here. So if it's in A through Z, then we want it to be, so if it's a capital letter, that's going to be the values 27 to 52. So then we want to grab the ORD for the capital letter. And there is this ASCII chart here. Look how old school this is. It's so pixelated and gnarly. But if we look in here, we should find character A. Capital A has the ASCII value of 65. So if we want the uppercase letter, the uppercase A should have the value 27. So I don't know, 65 minus 27, so 38. So I think we need to subtract 38 from this. So minus 38. I think that gives us what we want. Otherwise, we want to go all the way back for lowercase a through z. So let's look again. So lowercase a is 97. And in the lowercase, so lowercase should give us 1. So we want to subtract 96. I think this gives us what we want. Let's just see. In this case, we get 16, 38, 42. Okay, so let's see if that matches over here. 16, 38, 42, 22, 20, 19, 22, 20, 19. Okay, so this is exactly what the example suggests. And then we want to sum these up. So we can probably, I don't know, we can make this another one-liner and then dot sum. I love these pipeline things you can do in Ruby. It just makes it so clean. 157 is the example input. So what we want to do is grab our example output. So we're going to copy all of the rucksacks from the day 3 output. And we'll open up day 3 input. And now what we want to do is open up our implementation here. And we'll say that data is actually file.readlines of argv.first. And then we're going to say Ruby, I guess we have it over here, Ruby day 3, and then day 3 input. And we get 7,997, which matches my puzzle output. Great, that's part 1. So in part 2, we need to finish. So we finished identifying all the misplaced items. We like put them all in the right places. But now there's some like concept of badges. So each of the elves are divided into groups of 3. So when we're looking at our input here, like each of these chunks of 3 lines is going to be the rucksacks for 3 elves that are in a group of 3. And for each sort of threesome, there's going to be a value that is going to be the same in all 3 of the rucksacks. And so we want to figure out what is the value in this first threesome that is the same. And then we want to look at the second threesome and see what is the same value in there. So in the first group, the only item that appears in all 3 rucksacks is a lowercase r. So we see there's lowercase r in the first line, there is a lowercase r in the second line, and a lowercase r in the third line. So it's very similar to the first problem, right? But instead of comparing the 2 compartments, now we need to compare across 3 things. So what we want to do here is we're going to open up day 3, and rather than just splitting on, we'll just actually comment this out. So this is going to be part 1. And then for part 2, what we want to do is it's going to be super similar, right? So we're going to use the same approach where we're going to do like this intersection logic thingy. But instead of slicing the compartments in half here, what I think we want to do is we need to figure out how to group them by 3s. And yeah, so here let's use each slice again. But instead of using each slice to kind of like split it in half, we're going to use each slice to give us each sort of group of 3. And here we'll just say 2A, just so we can see what the result looks like. And we'll just run this against our example input. Okay, so here we get an array of arrays. The first one is the first 3 rucksacks for the first threesome of elves, and the second 3 is the second 3 elves. And now what we want to do is get the characters for each of the elves' rucksacks and then do the intersection of those. So what I think we can do here is say map each of the groups, and then for each group we want to map and get the characters. Thank you, GitHub Copilot. We'll run this again and see what we get. Okay, so now we have an array of arrays, and that looks good. Okay, so now what we can do is say map and do the same kind of like comparison between left and right, but instead of using left and right, now we'll just use 1 against 2 against 3, and that should give us like the intersection of 1, 2, and 3. And here we have lowercase r and uppercase z. So that's like exactly what we wanted again. And I think the priority for this second problem is going to be exactly the same. So then we find the priority for the items, we sum them up, and we should get some answer. So we're going to go through here and run this again. And okay. Oh, because we still need to flatten. And then we can run this again. Boom, we get 70. That is the test answer. Let's go up here, enable our file version. And now we can say day 3 with the input, and we get the value 2,545, and that is my answer. So if you're going through this, if you're following along at home and you're grabbing the input for your puzzles, your answers are going to be different than my answers. All of these are just like custom generated. There's a really cool talk on YouTube that you can head over and watch. It is all about how the advent of code is put on. It's really, really interesting. This guy, Eric, he goes through and collects and builds out all of these problems, and it's just such a fun time in December every year. So I would, if you get a chance, reach out, say thanks to Eric. And yeah, again, if you have your own puzzle, you're gonna get a different answer. So you can't just type in my answers, but hopefully you can follow the same patterns. And I'm also hopeful that you're learning a couple of things here and there. The things that were interesting about this episode was using each slice, and we used it twice. Once was to like split our rucksack into 2 different compartments. And the second was to group like threesomes of our elves into groups that we could then use to figure out which badges were in the compartments for those elves. Here we're also using regex, and I didn't really talk about this too much, but this right here is saying, okay, with whatever letter is passed in as the first argument to the block to map, we're going to use the, I don't know, this, someone called this something really funny. I thought it was like, it looks like a cigarette with like smoke coming out of it or something. And so we're comparing that against the regular expression A through Z, and that is inside of these square brackets. So this is basically checking to see, is 1 a capital letter A through Z? And if it is, we're going to subtract 38 from that because we want the value to be 27, 28, 29, 30, etc. for A through Z if it's capital. Here, this is going to be like, this is a ternary operator. So we're saying like evaluate the condition on the left. And if it's true, so if it's a capital letter, we're going to subtract 38 from the ASCII value for the character. Otherwise, if it's not true, so if it's not a capital letter, we got a lowercase letter, we want to subtract 96 from the ASCII value. That brings us all the way back down to 1 for lowercase a. So I don't know if this is how other folks are approaching this, but this makes it relatively straightforward. Also, if I'm using like way too many like fancy features of Ruby, let me know down in the comments. Sometimes, I don't know, for this year, I think it's pretty fun to just go through and build these pipelines that are just like, you know, step after step after step after step, and then just spits out a value at the very end. Ruby is just amazing. What a beautiful language. Thanks so much for watching. Really appreciate your time and attention. Hope you're having fun with the advent of code, and we'll talk to you next time.